Hi, students. So I just want to introduce Siddhat Shah, who's our guest speaker today. He's a search quality engineer at Google, and I'm sure he'll tell you a lot more about himself than I will. So without further ado, Siddhat, take it away.
Hey, fellow kids. You can call me Sid, and I work at Google and I work on search quality. So I have prepared a few things to kind of introduce myself, and I'll just jump into them. So, educational background, I did undergraduate study at Georgia Tech. I actually majored in aerospace engineering, and I currently have graduate studies going on at Columbia University, though I'm wrapping those up this semester. In terms of career history, I worked at Raytheon as soon as I got out of college, and now I'm working at Google for the past few years now. More on working on Google. So the product that I worked on is based on infrastructure for search verticals, right? So generally, when you like go into like a software company, there's like a whole stack, right, of like services that are interdependent, right? So search verticals are kind of at like the lowest layer. Like when you search like you enter a search and you see like a box pop up for cars, or you see a box pop up for like flights or something. Those are what we call verticals, right? And we built infrastructure for those verticals to basically provide good search experiences for users. Other things I did involved data pipelines and quality evaluation, which is just simply understanding how changes to code, how changes to like the system affects user experiences. So some interesting coding projects I've done either at Google or otherwise. Some of them include doing a distributed matrix library. At some point you might hear of I guess like execution framework called MapReduce. If anyone's ever heard of it, I don't know if you have, it might be a bit advanced, but I did a library to compute things using that. Additionally, I did a modeling project, which was based on the question of like which startups, which investments are good kind of short to long term returns, and how can you kind of maximize that based on some portfolio. And then one interesting one I think was trying to do algorithmic illustration of text, so generating basically imagery from some input text. So I also faced some personal challenges in my own life, of course, getting to where I am now. Some of that involves, not getting into the school that I really wanted to get into when I was in high school. And additionally, I've also dealt with issues where I've had to live like very far from home a lot of my adult life, and that can be a very isolating experience. And so dealing with that has in fact been like something that I kind of had to understand. I also have a lot of side interests. In games, I really enjoy strategy, deck builders. Reading, I of course like sci-fi and fantasy books, but I also read like some of those interesting books like Malcolm Gladwell. And I've been picking up guitar as one of my kind of enrichment hobbies. Yeah, I think that's pretty much the rundown there. I can open up for questions.
That was a great introduction, Sid. So students, please post your questions in the chat, or feel free to say them out loud if you would like, just to get the ball rolling. I love that your degrees, like you went from aerospace engineering to now what you're doing now. Can you talk about, sorry, thank you for pulling that up. And it seems like you had such a like non-linear career path. Can you speak to how that affected you, or
Yes.
Yeah, sorry, that was like a less formulaic question.
Yeah. So I would say that when I was in undergrad, I did pursue a minor in computer science, I think, because I recognized that there was a lot of value in understanding like computer architecture and how that was applicable to, I would say, like my first love in like the field of like, what I wanted to do with life, which was just trying to, design like spacecraft, right? Or like autonomous drones that would be used for planetary exploration. And at some point, I kind of got a little bit disenchanted with it because I pretty much believe that there's not going to be a Mars base or moon base in my lifetime. So I eventually ended up switching fields and joining Google. And that had been quite a tough transition because a lot of the code I'd written before in my previous job was not it was a different paradigm, right? Because what I had been writing at Raytheon had been like simulation code. And it hadn't been like involved with trying to interface with like the internet or a lot of the other things, right? So it was a very mathematical kind of environment, and that kind of didn't translate well over into what I would do at Google, which was very much, um, you know, trying to understand like all of these different like internet architectures because I didn't have like a full computer science background. So I had to do a lot of adaptation to kind of get there. So in short, yeah, it was a difficult kind of journey, but I think, an enriching one.
Thank you so much. I know that's like the hardest question sometimes, but thank you for highlighting that. And like, I just appreciate people that have really nonlinear career paths and your struggle there. I noticed we are also in grad school right now, but most search engineers don't usually go into masters, or do they? I mean, that's the big question. Why did you choose to go into a master's program? Also, someone says in the chat that they have some questions, so please post them and I will ask them.
Yeah. Yeah, so one of my interests, and I kind of picked up this interest while I was doing my minor at Georgia Tech, and this was kind of in like machine learning and like artificial intelligence, right? And I wanted to both simultaneously develop skills in um, like coding while I was working at Raytheon, and potentially it would give me like more marketable skills for like other careers, or even just like make me more in tune with what I would want to do with like those interest fields like machine learning and AI. So yeah, I think the master's degree, it has been useful because additionally a lot of careers that involve these fields that I mentioned do look for applicants who have like advanced degrees in the field. So it can be useful in that regard.
All right, we got some questions in the chat for you. Which classes did you take in your aerospace degree? Like what type of classes did you take? And
Okay.
do you focus on airplanes or on spaceships?
Essentially, aerospace engineering is primarily general early on, which involves like understanding fluids, and that kind of translates well over into aircraft design. As you get later on in the curriculum, at least as it was for me in Georgia Tech, you then get to get into like a spacecraft design, and there are a few classes that kind of deal with that. So I would say that primarily, like my senior design class was on spaceships or space probes or craft or whatever you want to call them. But so that was my interest area. I wasn't as interested in planes.
And then we had another question in the chat. What type of technology did you learn I assume this is in relation to the aerospace degree, but in general, I think that's good to know. What type of coding languages have you learned?
When you study aerospace, it's very expensive to actually test out or like do like physical design of whatever projects you do, right? So a lot of the technology used is actually just like test lab equipment, and they are like kind of these small scale testing, right? You don't build like large electronic assemblies to do spacecraft, space probes, right? Because it's mostly like system design. But when it comes to technologies that I use at Google, I would say programming languages are the primary thing. And those are kind of, I think my core languages are C++ and Python. I think both of these languages are very versatile. Python, I think, more versatile, but C++ being used for production, um, improvements, trying to write like the most optimized code. So when it comes to like machine learning and data science, if any of you are interested in that, Python is pretty much the language for it. So definitely look into Python, and I would say it's a very easy language to pick up. So it's worth playing around with.
Love it. Students are currently learning JavaScript, but I don't see why not. They couldn't learn Python. Thank you for your advice. We have a lot of questions in the chat. Some of them I'm going to smash together if that's okay. They asked if you learned a little bit of robotics or a little bit of astronomy. Also, is NASA in the area of aerospace engineering? Are they the main company that would be hiring you?
Yes, so NASA is one company that can hire aerospace engineers, right? There are other companies like SpaceX. You can sign up with Elon and he will maybe get to Mars, who knows? But yeah, when you study aerospace engineering, astronomy is not actually like a core part of it. You can take astrophysics classes. It's more aligned with like the physics department. Astronomy itself, you can take as like an elective, right? I think if you're curious to know about like stars and galaxies, there are classes you could take for that. But I think overall, you would probably instead just like kind of learn about those things on your own. Or if you were, an like a physics major, right? Because that's where there would be like actual interesting theoretical questions abounding. Regarding robotics, however, yes, I did learn about robotics. So yes, understanding like planning, when you have like a $1 billion spacecraft and is like sent on its own out to some planet, and it takes literal minutes for light to even like travel back to Earth and even like get some kind of response, right? You need this spacecraft to act autonomously, and you have to understand what kind of problems might arise in that sort of space environment, how you can get your spacecraft to kind of navigate itself without your intervention. And that is kind of one of those applications of robotics.
Thank you for that explanation. A lot of our students just made robots recently, so the peak of interest in robots is very keen.
Nice.
Just a few questions, just to transition us a little bit from aerospace engineering, because I know right now you're working at Google. Can you talk a little bit, you already mentioned this, but what exactly is a search engineer for students that don't know entirely? And what are other careers in this field look like?
Yes, so a search engine is something that helps you find documents, right? you're going to have like important pieces of information, right? And you probably heard of like a database, right? And with a database, you can like very specifically look up like, you know, I want the record for Mary, right? And I just type in Mary's name and it'll give me the record, right? But when you like, what if you only know Mary as like Marianne, right? And you type in Marianne in the field, and then suddenly like it doesn't come back, right? Because the database doesn't know where to look. You need something more powerful than that, and that's where like you know, search engines that have like, you know, these powerful algorithms come in and try to help you find what you're looking for, and that's what the business of Google search. So as a quality engineer, what I do is essentially help people find what they're looking for, right? And sometimes people don't even know what they're looking for before they search things. And we sort of have to kind of provide like this user experience that lets them explore and like figure out what it is that they kind of want to look at and potentially click on.
Perfect. Thank you so much. And we have one more question in the chat. How did you study hard engineering? Like, how did you go about it? How did you get interested? I'm going to interpret that question as.
It seems like they're asking how hard it was to study engineering, or is it how did I get into an engineering field that is difficult?
However you would like to interpret that, it is up to you.
Right. So definitely these fields are technically, you know, elevated. You, in order to make improvements on something that's already good, right, you have to be even better than what already exists. And of course, what already exists has been created by someone who has already, you know, proven themselves to be better than what existed before that, right? So in a sense, you do have to work hard in order to succeed in the engineering field, right? Or at least make a difference. There is like I would say if you're not in the field of if you're not in the business of trying to make something better than what exists as it is now, right? Then I would say like engineering is probably not what your like overall goal is, right? Like that is kind of the heart and soul of engineering. So you should be willing to kind of work hard and be able to kind of experiment and kind of try to like glean some information out of what already exists.
Yes, the next question is, what is the most fun part of aerospace engineering?
A lot of the fun in aerospace engineering was kind of doing systems uh, engineering, right? Trying to put together multiple kind of like small components into something that works, right? Like building out this mission that, and that involves kind of like, it's kind of like a jigsaw puzzle, right? You see what is out there, right? And you see like what is the science opportunity, and you try to get as much of that science opportunity as you can. It's kind of like this greedy kind of objective. And you're just trying to kind of fit these pieces together to make it work that way. And potentially along the way, you're saying like, okay, this piece, if it was just a little bit better, maybe we could have it work, right? And then you actually go into that piece and you start seeing like how that can be improved. And that is itself kind of like an investigation, right? And I found that very gratifying in aerospace engineering. But that kind of comes in later on. Early on, you're learning about like a lot of physics and like understanding like fluid dynamics. So, you know, the I would say the fun part of aerospace engineering comes later in the studies. So there's kind of a delayed gratification.
Perfect. Thank you. A student asked also, I want to know what was the most important skills you learned in your aerospace engineering degree? And I'll add to this, how do they apply to your current day-to-day job?
Okay, so let's see. I would say that aerospace engineering definitely gave me an understanding of like planning, right? Because when you are an aerospace engineer, you have a very low tolerance for risk, right? These are systems that have a lot of people that depend on them, and failures can be absolutely catastrophic, right? And so you kind of have to understand like, and sometimes even like over engineer, right? To have like some kind of tolerance that can ensure that, nothing too bad ever happens, right? But of course, in any kind of engineering environment, failures can happen. The hubris of thinking failures won't happen is often what causes it. So you do have to be careful, right? When you translate that over into computer science, the failures are not often as catastrophic because we're not talking about human lives generally, right? There are applications where, human lives are on the line, but those are a lot less common, I think. And understanding kind of how to kind of like mitigate things is a skill that's kind of applicable between these two fields.
Perfect, thank you. And I'll ask the last question. What is your day-to-day life look like at Google, and what is it like working at Google?
So when I joined, it was back in 2019. So I'll talk first about my time while I was working in the office, and then around like this time last year, we were sent on a semi-indefinite work from home. So there was kind of two phases. One was I was going to the office, and then one was I was kind of working from home. And so while I was going to the office, it was enjoyable, right? Like Google provides, nice benefits there. You can, get free food from the recreation lounges, and you can just kind of just take what you want, take a nice bite to eat, go back to your desk, right? And you have your coworkers around. Naturally, your day is slotted with coding, right? But you also have to take meetings and kind of do the engineering aspect of it, which is just kind of agreeing like what the system should look like, what the system needs, and like satisfying those needs. So that's kind of the day-to-day of that job. Then working from home, I then have to at that point I have to make my own lunch again because they would give us free lunches at the cafeteria. The frequency of contact, of course, with coworkers does diminish with the work from home, but we managed to keep some level of like kind of shared team activity even through this work from home experience. So generally, yeah, like the day looks like coding plus chatting with coworkers.
Fantastic. Well, thank you so much for answering all of our questions today.
Mhm.
And students, if you can give him a virtual round of applause. But thank you so much, Sid.
Oh yeah, yeah, no problem, Alexa.